Hello everyone, my name is John Soul, Solutions Architect with AWS. In this video, I will discuss how customers can modernize their document workflows using AWS Intelligent Document Processing solutions. At AWS, we built IDP to allow customers to take advantage of industry-leading machine learning technologies in their document workflow without the need for ML experience. The foundation is our OCR technology that has industry-leading accuracy. From there, we are able to use ML to extract information for popular document types such as forms, tables, invoices, and contracts. Our ML also provides you the capability to analyze the documents to classify them into types, such as identification documents or tax forms, as well as recognize entities unique to your business, such as driver's license or prescription number. One thing to keep in mind when moving to IDP is that the software costs typically go up compared to legacy solutions, but the overall costs decrease as less human input is needed per document and accuracy improves, resulting in fewer bad decisions caused by inaccurate information. Overall, you will be able to serve customers faster since IDP's scalability removes document processing as a bottleneck for your business's growth, and it is much easier to handle spiky workloads while not paying for excess capacity during lower periods of demand. IDP is used across a variety of industries. For example, in finance, IDP is used to extract information from documents to support Know Your Customer processes, process account applications, and obtain credit reports. In the medical industry, IDP is used to extract information from prescriptions, handle insurance forms, and convert handwritten notes to text. And in the legal field, IDP is used to handle discovery documents, legal filings, and contracts. These are just a few of the ways that IDP helps customers optimize document processing. Let's see what a typical IDP pipeline looks like. Going from left to right, it starts with capturing documents in S3, our highly durable and scalable object store. Next, Amazon Textract takes the input document and extracts the text. Amazon Comprehend then analyzes the text to classify the document according to categories defined by the customer. Once the document is classified, it is routed for further processing. These routes are defined by the customer's own business rules. For example, driver's license documents may be sent to a Know Your Customer workflow that will extract the first name, last name, and driver's license number. Or a medical document may be routed to Comprehend Medical to identify key health entities such as medical conditions, medication, and treatment. Or legal contract documents may be sent to a contract review workflow. Humans may be part of the document processing pipeline also. For example, humans may check any low-confidence extraction of text and make corrections if needed, or they may provide a final check and verification and provide their stamp of approval before sending the documents downstream to back-end systems. So how do customers get documents into S3? Well, because S3 is so flexible, customers can store any type of document, from scanned images and PDFs to Word, Excel, and text files. Document sources may range from physical mail rooms with scanners to desktop computers or camera phones, or even documents sent through FTP, text messages, or emails. You may be already familiar with Textract's text and OCR capabilities, but we also offer support for handwritten text as well as the ability to extract more complex structures such as tables, key value pair information, and signatures from a wide variety of forms such as financial statements, loan applications, insurance claims, clinical forms, and even offshore drill documents. Another capability of Textract is specialized document support based on customer feedback. Customers told us that they love the accuracy that Textract's generic tables, forms, and OCR models provide, but that they want our help in deriving additional domain-specific inferences for their most valuable documents. We have 3 dedicated APIs to tackle important domain-specific use cases. The first, Analyze Expense API, is dedicated to the processing of invoices and receipts documents that helps customers automate the process of processing their accounts payable, invoicing, expense management, and other workflows that have been historically very difficult to automate. The second is Analyze ID API, which is dedicated to data extraction from identity documents such as passports, driver's license, and state IDs issued by the United States without the need for any templates or configuration. The core use cases for the Analyze ID API are identity verification, online registration, and billing. The third is Analyze Lending API, which enables our customers to efficiently process mortgage documents such as mortgage statements, bank statements, and payoff statements. Another capability is Textract Queries, which is a pre-trained out-of-the-box AI feature that provides customers the flexibility to specify and extract the data they need without worrying about the structure of the data across a long tail of diverse documents, formats, and versions. This is an example of using multiple tools to extract information from a single document. The top row is using the output from our OCR software. Without the advanced ML features, your developers would need to create the post-processing rules to extract the important business information for your downstream business systems. We have the ability to process both typed and handwritten information. The advanced forms capability is able to identify that the job fair checkbox was checked, but the website was not checked. And finally, our tables capability is able to identify the information within the tables while maintaining the key relationship between the columns and the rows. Document classification is used when customers have different processing requirements for different types of documents. For example, from a bank statement, you want to extract the date, the amount, and whether it was a credit or debit for each transaction, whereas from a pay stub, you want to extract the gross pay, the deductions, any taxes, and finally the net pay. Document classification is accomplished in Amazon Comprehend by creating custom classifiers. Training Comprehend with a custom classifier is straightforward. Customers simply need to provide examples of each type of document and provide a category for each type of document. Comprehend uses multiple algorithms in the training process and picks the model that delivers highest accuracy for the training data. This way, users don't need to deal with the complexities of choosing different algorithms or running iterations and then determining the best ensemble of algorithms. They simply need to provide training text, and Comprehend does the rest. Once a model is trained, users can reference it by name and run inference jobs either in real time or asynchronously. Real-time classification takes only one document and returns the result synchronously. Asynchronous classification can process multiple documents at a time and stores the results in an S3 bucket. Amazon Comprehend may be used to support a variety of use cases. For processing sensitive documents that contain PII or personal identifiable information, Comprehend can detect and optionally redact PII data in the document. Comprehend also may be used to find common entities within the document, such as organizations, people, locations, dates, quantities, and titles. And finally, customers can train Comprehend to detect custom entities, such as insurance policy numbers, product codes, or occupation. The goal of IDP is to reduce the amount of human input required to get accurate information into your decision systems. In prior generation OCR, a human was often required to review all or most information. With IDP, you are able to reduce the amount of human input for your document processes. Many customers plan a multi-step journey to implement the people, process, and technology change in their document processing workflows. While the end automation goal is set by your business needs, we find that customers who take a phased approach to implementing automation are able to see both quick wins and reach their long-term goal. While the end goal could be 90% automation, starting out with quick-in projects that deliver 25 to 50% labor savings is often the best way to get started. The core services in IDP, Textract, and Comprehend are great at extracting text, classifying documents, finding entities, and more. By utilizing generative AI and their foundation models, or FMs, that are trained on vast amounts of data, the core IDP services can be augmented with new capabilities. For example, the IDP text output may be summarized by FMs to help readers focus on important points, or the text data may feed a corpus of knowledge that FMs may use to answer questions through a chatbot interface. FMs may also be used to normalize data formats, correct punctuation and grammar, or handle low-confidence results that would normally be handled by a human. These few use cases are just the tip of the iceberg of what may be achieved by using FMs. Let's revisit the IDP document workflow to see where FMs can add value to the core IDP technologies. Within the classification stage, oftentimes when Comprehend returns a low-confidence result, a human is required to manually classify the document. Instead of interrupting a person to review the document, FMs may be used to classify the document. In the extract and enrichment stage, FMs may be used to summarize document text, normalize outputs, for example, formatting all dates in month, day, year format, or provide a natural language chatbot interface to interact with the document data. In the verification and human review stage, humans may use FMs along with Amazon Kendra, the AWS Enterprise Search Service, to help verify the final output. At AWS, security is top priority. Access control is managed through the AWS IAM service, and data confidentiality is maintained through encryption both at rest and in transit. Amazon VPCs, or Virtual Private Cloud, provides a logically isolated network to deploy your workloads. And AWS provides services that enable our customers to meet their governance, risk, and compliance requirements. AWS customers may check the compliance status of each service to determine if it meets their compliance needs. For example, Amazon Textract is in scope for ISO 27001, SOC, and HIPAA compliance. In the following demo, we will see how IDP can help optimize insurance claims. This is an example IDP flow where the goal is to reduce the amount of time it takes to process an insurance claim. This improves the customer experience while reducing the cost of processing the claim. While the specific business rules and documents would differ, the overall flow is similar for other use cases, such as quoting new business or handling dispute or resolutions using the same underlying AWS AI technologies. This demo walks through the process using an example UI from a claims admin perspective. In real implementations, the claims would be processed automatically at high volumes. Humans would use dashboards and provide human-in-the-loop judgment as required by the business rules, and this functionality can be integrated into your existing workflows and agent tools. One of the benefits of IDP is the ability to handle easy yes or easy no decisions based on the customer's business rules. Humans or other advanced decision systems can be used to handle complex decisions. Over time, the share of decisions made by automation can be increased. One of the biggest challenges faced in document processing is ensuring all of the required documents are included in the claim file. Looking at the third claim, you can see the claim didn't have the required documents, and the customer was notified that they need to upload the correct documents in order to reprocess the claim. Quickly alerting customers to the need for more documentation reduces the overall time it takes to get their claim paid. The second claim successfully went through the document pipeline and was auto-approved by the business rules without human involvement. Now let's take a look at the first claim, and we can see how the process works. Claims documents can come in from multiple channels, either through mailrooms, emails, portals, or even through the user's phone. And figuring out what you have is the first step. Today, this collecting and sorting process is often handled by human staff. If they make an error, a claim could be delayed or incorrectly denied. Let's click on a few of the documents to see what sort of documents our member sent in for their claim. So in this claim, this document, the claimant sent in the health insurance claim form. Let's look at document 3. This document looks like a scanned image of the insurance card. And finally, let's look at document 7. This is a scanned image of the claimant's driver's license. Figuring out what types of documents that are included in the claims documentation is the next step. It is important to know if we have the minimum required documents for a claims decision. The third auto-rejected claim on the prior page did not have all of the documents, but fortunately this claim has all 10 of the documents that are required. Our AI was able to recognize and label all 10 of the documents, but the confidence score of the third one did not meet the business requirements that require human review of scores with a less than 85% confidence level. Let's take a look at the document that needs review. It is the insurance ID. And we can see this is the scanned image of the insurance ID. And in this example, this would typically be sent to a human-in-the-loop review, where the human would take a look at the document and update the information if needed. In the fifth document, we see that the confidence score is less than 11%. Let's take a look at this document. This looks like a claim document sent in by the customer. And here we can see how using generative AI's foundation models can help with classifying this. So we can launch a LLM classifier, or where an LLM is a large language model, which is a type of FM. And the LLM is used to classify the document. Here we select that the output that is returned by the LLM, and its decision is that it is an insurance report. We agree with the decision, and we select OK. And the indication is that this was manually classified via a LLM. Now that the documents are classified, let's go to the next step. Looking at the CMS 1500 form, the AI is able to read the key value pair and structure the results so they can be easily used by your downstream business systems or databases. So here, if we select some of these fields, we see that the pick boxes were not selected, that the group health plan was not selected, or that the FECA block for lung was not selected. Here we see the insured's ID number. And we can look at one more field, the patient's name. We see that this was captured. Now let's take a look at some of the table data. We see at the bottom of the form, there is a table which our AI was able to detect. It detected the columns as well as the rows and maintained the relationships between them. We are also able to provide a query against the document. This would be useful when you do not know what the fields are or if the fields vary between documents. Let's look at a query. So here we're querying the insured's ID number, and we get back the correct answer with a confidence level. And notice here that we are not referencing the field by name. We are simply asking what the insured's ID number is. This is also good at capturing signatures. So we see the signature captured here. We can also collect the raw text of the information. Now, for those cases where there is a low level of certainty, we can send this through a human-in-the-loop review via our augmented AI feature. Now, let's take a look at some of the other documents. Here we see an explanation of benefits, and the same form capability is used to capture the form information, as well as a table which is contained here. Here is another example of a query. So here we're asking who is the employer. Now let's take a look at the insurance card. Here we see that the key value pairs are extracted from the card. Now let's take a look at how our AI processed the driver's license. Many documents have implied fields. Our AI understands that the person lives at 123 any street in this example, even though the field isn't labeled. Our technology also normalizes field names across ID documents, such as last name, which in this example is listed as LN, and on other IDs, it may not be listed at all, or it may be listed as last name. This also prevents a mistake of recognizing the person's name as LN Doe. Similar to the ID, our AI also has advanced capabilities to understand invoices and receipts using implied context and standardized field names to reduce the amount of processing effort. For example, you can see fields such as subtotal, the discount, the tax, and the total, which is displayed over in this section. We can also use a similar capability to the tables we saw on the first form, and we are able to find line item details from the invoices. Once we've extracted the document, we can then process the document information further. Many businesses need to find information that is unique to their use case within dense text documents. You can train our AI to recognize entities such as the patient's name, the date they were admitted to the hospital, or their patient ID. As with all of our AI predictions, a confidence score is included so that you can have a human double-check the AI based on your business needs. The capability to train the AI to find entities specific to your business can also be useful in other dense text documents, such as legal contracts. Now let's take a look at how generative AI can be used to augment the core IDP technology. In this insurance report, we see how a LLM, which is hosted on SageMaker, can be used to summarize the information contained in the insurance report. We also can use the generative AI to ask questions to find information about the document. In this case, we are asking what is the patient's chief complaint and how long has the patient been experiencing it. And this returns back with the answer that the chief complaint is a lower back pain and has been experiencing this pain for approximately 1 week. You can imagine this being in a chatbot context where you can ask questions dynamically and then be returned answers. Let's take a look at the medical transcription. Here we see that the transcription document was scanned askew, but the IDP solution was able to accommodate this and extract out the information correctly. One of the challenges in processing unstructured medical text like doctor's notes or clinical trial reports or radiology reports is finding enough qualified staff to extract the medical information. Our health AI can identify relationships among extracted health information and link it to medical ontologies such as ICD-10 or SNOMED. And finally, let's take a look at how the IDP solution is able to extract information correctly out of an image of a medical prescription. Here we see the image. It's kind of glossy, somewhat difficult to read, but the IDP solution extracted out the information correctly and then linked it to the RxNorm medical ontology. Now let's see how AI can help identify and redact PII and PHI information. In this example, the names of the doctor and the patient were identified as PII. The IDs were identified as well, and the date of birth and the date of the procedure was identified. Now let's take a look at how Gen AI may be used to further enrich this document. Gen AI may be used to normalize information into a standard format. So in this case, it is taking the dates and normalizing it in standard format, in month, day, and year format. You can also normalize the names into a standard format of first name and last name. Now let's take a look at how generative AI may be used to further enrich and process information that's extracted out from handwritten notes. In this case, the information was extracted out using Textract, and you can see that some of the extracted text is not correct. For example, patient John Doe, who was admitted with severe neck pneumonia, has shown SIGIF. So there are multiple mistakes here within this extracted text. We can send this information into the LLM, which will correct the text, including grammar as well as spelling. And here we see that admitted was corrected to admitted, and that necronia was corrected to pneumonia, as well as signifiart was corrected to significant. And finally, after processing all the documents, we are at the review and validation stage. Here we can see that we have collected and processed all the documents within the claim, that we have extracted out the requisite key fields with the correct confidence level. And then we have cross-validated the information from documents. In this case, we have cross-validated that insurance IDs in the claim form matches the member ID in the insurance card. And similarly, we have correctly verified that the patient name in claim form matches the name in the identification document. So once all this has been reviewed and verified, we can send it down to the downstream process. This concludes the presentation about IDP at AWS. We learned what IDP is, how it helps customers optimize their document processing workflows, and how using generative AI can augment IDP by creating summaries, normalizing outputs, and providing a natural language interface to interact with the document data. Thank you for your time and attention. Please contact AWS if you would like to learn more.